What if you stood on the lunar surface and decided to jump? Not just a small, cautious hop like Neil Armstrong, but a real, powerful jump, with every bit of strength in your legs. Would you become a superhero for a moment, soaring high above the grey horizon? Or would this harmless experiment turn into a disaster you never saw coming? You see, on the moon, everything, absolutely everything, works differently. The laws of physics your body spent millions of years evolving to master suddenly glitch. Gravity, inertia, even sound. The moment your boots leave the dust, you'll realize this isn't just fun. It's a trial for a biological machine that was never designed for life in another world. Let's start with the numbers. Gravity on the moon is only about 16% of what it is on Earth. Put simply, it's 6 times weaker. Imagine this. If you and your bulky spacesuit weigh 260 pounds on Earth, on the moon, you'd feel like you weigh only 43 pounds. You'd feel light, nimble, and incredibly powerful. Your muscles, conditioned to fight Earth's heavy pull, suddenly become overqualified for your body's weight. On Earth, the average person jumps about 16 inches high. On the moon, that same effort would launch you over 10 feet into the air. You could easily dunk a basketball on a regulation hoop without even breaking a sweat. But the most surreal part is the timing. On Earth, a jump lasts a fraction of a second. On the moon, you'd stay airborne 6 times longer. It would feel like a slow-motion movie. You'd have time to look around, see the curve of the lunar horizon, and gaze into the black abyss of the sky before gravity lazily begins to tug you back down. It sounds like the ultimate playground, doesn't it? But there is a trap. While you weigh less, your mass remains exactly the same. And that means inertia is still very much in play. When you push off, your brain expects Earth-like resistance, but there is none. You accelerate upwards so fast that your body might start to tumble uncontrollably. The center of gravity in a spacesuit is awkward, shifted by the heavy life support backpack. If you push just a little harder with one leg than the other, you'll find yourself spinning through the vacuum, flailing your arms. The Apollo astronauts faced this constantly. They couldn't just walk. They were perpetually tipping over or pitching forward. To stay upright, they had to invent the lunar lope, a hybrid between a run and a kangaroo hop. It looked funny on camera, but it was the only way to tame the moon's strange physics. Trying to stop suddenly after a jump is just as dangerous. Your feet might stop, but your upper body's inertia will keep moving, sending you face first into the dirt. Now, imagine the moment of landing. On Earth, you'd hear the thud of your boots, the crunch of gravel, or the rustle of grass. On the moon, absolute zero. A total vacuum means there is no atmosphere to carry sound waves. You could set off an explosion next to you and hear nothing. Your landing after a 10-foot jump would be completely silent to the outside world. The only sounds you'll hear are the hum of the cooling fans inside your helmet and the sound of your own heavy, echoing breath. This sensory deprivation, the lack of sound associated with movement, is deeply unsettling. You might feel the vibration through the soles of your boots, but your ears will tell you that nothing happened. The moon is a world of eternal silence, where every movement is a ghost-like intrusion. The greatest danger, however, is what you are landing on. Lunar regolith. This isn't soft beach sand, it is rock that has been pulverized over billions of years but never weathered. On Earth, wind and water smooth out sand grains. On the moon, every speck of dust is as sharp as a shard of glass and as hard as a diamond. When you land after a high jump, you kick up a cloud of this dust. It instantly clings to your suit due to static electricity. Regolith acts like a high-grade abrasive. It eats into the joints of your suit, scratches your visor, and can tear through the specialized fabric layers. One bad landing, one slip onto a jagged rock, and a micro tear in your suit turns your adventure into a fight for survival. On the moon, a fall isn't just a bruise. It's a risk of depressurization. Could you jump into space forever? No. You'd need to reach 2.4 kilometers per second to escape the moon's pull. Human muscles simply aren't that strong. You won't float away, but for a second, suspended in the void, you'll feel free from Earth's chains. The moon is majestic but deadly. We are built for heavy steps and thick air, not this silent desolation. Here, even a simple jump is an act of bravery. Would you take the leap or stay on the safe ground of home?